I had to present the material to them, and I did have, oh my goodness, I got quite a few TAs. And the TAs, for goodness sakes, they scored my exams and quizzes for me. They created the exams and quizzes with my help. All I had to do was teach the class. Then I went back to my office and did research. I had to just teach the class, Miriam, and then Miriam was my TA, and all of a sudden she has a session on the outside like my students here do, and you went to them to answer a question. Can you imagine trying to ask a question in an auditorium with 100+ students? It doesn't happen. You know, you'd love to raise your hand and say, Professor Ramsey, I didn't quite understand that. You know, sometimes I wouldn't be able to see you or hear you. So what you did, you just kept it in your mind and you went to check one of the TAs to help you. That's what those TAs are for. Now, on this though, chapter 4, here we go. I have, and Mr. Parker, you got a copy of that, right?
Mm-hmm.
Okay, did we have any left over?
No.
Oh, we didn't have any left over?
No.
Wow, my class is here today. Okay. Guys, let me give, yes. I got you. We're going to start out with part 1. Different concept altogether. I'm going to call this, name it, as this. Composite functions. I will tell you ahead of time, don't worry about an asymptote. It's not here. Don't worry about a limit as x is approaching infinity. It's not here. This is a different topic altogether. Now, the way I'm going to lead into it, I have these two functions given to us to work with. Given, I've got f of x. In this case, it is given to me as this: 2x squared subtract x plus 3. I have another function, try a different color to hit for a reason, and it's merely g of x is equal to x plus 1. Let me step back and look at it. It looks good. It's okay. You know what? Hang on. Let me make that subtract 3 in the end. Just for a reason. Because 2x squared subtract 3, then the x plus 1 for the g of x. Those are the two that I have to work with. Now, they want you in chapter 4 to take those two functions and put them together. Don't graph, put them together. You say, Professor, how are you going to put them together? One way to put them together, they say, combine them. I could ask you to find, number 1, find f plus g with respect to x. If I saw that written, that merely says take those two functions and add them up. And that's the answer. That means, guys, if I add these up, I got 2x squared, subtract x, subtract 3, and you're going to add to it x plus 1. That's all it says to do. Put them together. Collect like terms, you end up with 2x squared, and it looks like the x's may cancel, and it looks like it may be a -2. You guys check and see if I'm correct. Top of the board here. I think it's 2x squared subtract 2. You guys agree? And that's the answer. Oh, Professor, give me more of these. Let's stay away from those rational functions. The vertical and horizontal and crossover. No, give me more of these. Number 2. Another way to combine the two functions in chapter 4. Find their difference. No problem, Professor. This function, subtract this one. You guys, if we know our algebra pretty well by now, if you do that, make some sign changes, and collect like terms. I'm doing it myself here. You're going to end up with 2x squared. As we look at it, I think you're going to end up with minus 2x. And I'm checking here, maybe a negative 4, and see if you guys might agree. Would I end up with that if you actually do the algebra there? And you could actually, if you want to say, Professor, could I take out 2 to make that look a little better? Well, if all that's correct, and let's hope it is, you could make it look like that. So wait, did anyone try this also with me as we're doing this? Did you get that? Can you subtract the 2? Yes, no? Number 3, Jonathan, they did ask you to combine the 2 by doing this. Represented as find the product. Now that may take a little bit more effort, but it says do this. 2x squared plus subtract x, subtract 3 times x plus 1. I'm not going to do it today because I didn't need my time, but that merely says multiply it out, expand it out, which will take a little time, but you can do it. Number 4, to combine the 2 functions, another way to combine is to find the quotient. Last was the product, now the quotient. Easily done. It says place 2x squared, subtract x, subtract 3, over x plus 1. Now, if, I don't know whether it's going to work or not. If this on top would factor and something cancels, I could actually simplify that. Hi guys, I'm staring at it. I don't know. Does anyone think it might factor the top? If it does, I could simplify my answer. I don't know. With your help here, guys, here goes. We'll try 2x and x. It may not factor. Minus 3. Oh my goodness, it is. Are you kidding? Check my factoring, guys. Is that factored correctly? Yeah. And still over x plus 1. Oh, Ramsey, you are good. Let's cancel. Therefore, your simplified answer for this quotient is 2x subtract 3. Yeah, thank you. Now he said, Jonathan said, well, I'm making a connection, Professor. I know, Jonathan. I know you're better now. This is a rational function. I'm not thinking of it as a rational function in chapter 4 right now. I'm thinking of it as a quotient. But it's a rational function. And he says, Professor, you mean if you would ask me to graph this, then I'd have to go back to what we were doing before the break? Yes. You would. But right now, no, I'm just asking for a quotient, simplified, and I'm going to ask you to graph this in chapter 4. Number 5, though, it all leads to this. And let me make sure these markers work. Okay, number 5. That'll be better. Another way to combine. F plus G, no. F subtract G, no. Product, no. Quotient, no. So what's another way to put those 2 functions together? It looks like this. Looks like a little circle between. And they give a name to it. It's not addition, it's not subtraction like I did earlier, it's not multiplication, it's not quotient, it's called a composite. So there's another way you could put those 2 functions together. To do it though, its name is composite, you do it this way. By definition, it's f of g of x. That's what it means. That means in my case, if I'm careful, I'm going to go back. It says g of x. Well, I gave you g of x, so this is x plus 1 in the red. It's asking for a composite to be found by taking f of x plus 1. You're going to love these. You're going to love these, Miriam. Michael's going to tell the professor what to do, and I'll go back to that. Those asymptotes, and the approach from the left, and the approach from the right, and Professor Ali went crazy on that stuff. This though, finish it up. Go back to your function, be patient, right here it is, and replace all those x's in your f function, the blue one, with that x plus 1. Now we'll do it fairly quickly, guys. Just to point out what it means. I'll be patient on this one. You put an x plus 1 in here. And where it says the squared, back to the original. Then subtract again, x plus 1. Impatient, and then subtract 3. Now, to save me time, you know you would have to clean that up. You have to expand it out, collect like terms, and so forth. That can be done easily by you, but that's what it means to do. Number 6, I'm squeezing it in, guys, right here. It may be turned around like that. G, a little circle, F. G composed with F, another composite function. It means, if it's in this order, it means G of f of x. If it's in that order. That says go to your G function, that's my red one, and put the blue. So if I go to the red one and put the blue, guys, I think, help me out here, we're going to have 2x squared, looking back here, plus, where is it? Subtract x, subtract 3, and if I put the f into plus 1. See if you guys agree. Is that placing the f function into the g? Would you get something like that? Answer, easily done. 2x squared, subtract x, subtract 2, we can combine the numbers, and Miriam, on this one, you're finished. Whew, isn't that nicer? You might even play around with it. It might factor, who knows? You might factor it if you had to factor. But right now I'm happy. Nima. Number 7. I'd like to find this. That composite. Little circle in between says now find the composite of f with itself, which means, by definition, f of f of x. These can get crazy on us. That means, guys, here goes, f of x, the original blue function over there was 2x squared, subtract x, subtract 3. And you still have this on the outside. What on earth does that mean to do now? How am I going to finish that composite up? What's it mean to do? It's going to be a little messy. What's it mean to do? It means take that blue function and put it right back into itself. If I do, that means go back here, and here goes. Don't let me mess up. This is 2 times, here goes, 2x squared, subtract x, subtract 3, put in there, that's been squared, subtract, here we go again, and there was a subtract 3, I think, on the end, down here. Did I put those in correctly? I'm not going to attempt to simplify that. No. Okay, and the last one, which you could write for a composite for us, number 8. Let me put it up here. They ask me to find G with G, which means this. Place G into itself. This is going to be easier. Here's my red G. If I take it back into itself, Please tell me, does that mean, help me out here, x plus 1 plus 1? Yes or no? I hope. Which is essentially what, x plus 2? And you have all of the so-called composites placing one function into another, done. Arbad, what's so hard about this? What's the issue, Professor? What's the issue on this? So far, nothing. But something's going to come in part 2. Yes?
But if we ever get this on a test, which we will eventually, will we have to multiply out
You
number
do.
7?
Whoa. You're talking about up here, this one, saying, oh my goodness, Professor, would you actually ask me to expand this mess out? Miriam, no.
Thank you.
I'm not gonna ask you to multiply all this mess out, but right there, just square that part right there would take some time. No.
Okay, good.
No. As long as you have said it for me. Now, if it's a more simple one, I may ask.
That's
Go
fine,
ahead
as
and
long as they're
simplify
not
it. Yeah, like the red would come up to be what? X plus 2. Something like that. Now, here's the issue that could happen, and I got only a minute or whatever. And I got closed down. At least I got an introduction to this chapter. Here we go. I'm bringing this up for a reason. The blue is the way we close. Let's go back to the blue. I'm finished with my composites. The blue one, can anyone tell me? This won't play a part on these composites tomorrow. What is this domain? The blue one? And all classes that can answer this, you guys can answer. I've asked this question in many semesters. Can anyone just take a look at my blue function, which is a quadratic? It would graph into a parabola. In fact, a parabola opening up. I know all that business. So what is its domain? What am I allowed to replace x by? Go for it.
Negative, infinity, positive.
Thank you. All real numbers. Now, I've been waiting for this. Oh, I've been waiting for this to close down. Been bragging on you guys. I told you I was talking to one of my colleagues yesterday. He's asking, got any good students around? Got any good students? I don't have any good students. Don't ask. No. He wanted me to send my good students to him. I told him I didn't have any good students. You don't have any? I don't have any. Arena, we don't have any, do we? In this class, well, we don't have any good students. Oh. That's just let him know. Don't ask. Of course, I got tons of good students, but you're not going to get the names. To answer this, the domain's open. Now, this is so nice. I love to close down classes like this. Now I'm looking for the range of that blue function. The range, not domain, the range. Nima,
Yes, can we say
what do you think?
1 over 4 to positive infinity?
Hold on. We'll work it out here. I have some strong students in this class. Exactly, that's what Jonathan expressed it perfectly. If I were a student seeing that, I'd say, what? What does Nima know that I don't know? He says, Professor, should it be a bracket on the 1/4 or not?
Yes.
Okay.
Bracket.
Okay. Professor, how can Nima look at this blue function and tell you the range, the up and down on it, that quickly? Wow. Now, and we're going to close down with this. Oh, I love this. Nima, let me ask you though, what you were processing, and I'll try to relate it to what we just recently did not too long ago to make this connect with something we've already done. Because I love to make all these topics connect. What do you think of?
Well, the coefficient is a is greater than 0, so this shape is upward.
Oh, whoa. Yeah, graph that, it would graph into a parabola opening up, 100%. Tell me more.
And then I use vertex formula minus
Oh.
b over 2a.
He says, Professor, hold on, that's the vertex, that's my turning point, which in this case is the minimum. And he said, Professor, I can find that minimum. How? He says, I'm gonna use that vertex formula we've been using, that's the vertex, negative b over 2a, negative b over 2a, negative b over 2a. And, Nima, did you use that other strange formula to find the y, or did you do f of that?
Or just for f of x.
Okay, we'll just do f of that, and not use that 4ac minus b squared over 4a. Remember that one, guys? Class? He says, after you find this, professor, find f of this. I'll read quicker. He says it comes down to a max or min, depends upon negative b over 2a. We talked about this in class. So this is negative. B in this case is negative 1. Twice a, twice 2. Here goes, hang on now. Did I put those incorrectly? That's negative b over 2a. Did I put my replacements incorrectly? B in the 2a. And what is that? Positive what? 1/4. Now I heard him say 1/4. Well, it's not quite finished. Nima, genius. Genius. That's what I want to hear. But you're not quite finished. So I'll do this for you. Oh, you are almost there. What must I do now that you're actually telling me? What should I do in addition to that? Yeah, now take the 1/4 back and plug it into the function, find f of 1/4. If I do, here it goes, a little bit of here. F of 1/4, that is equal to 2 times this, this. Arithmetic, I know this is 1/16, let me get this done real quick. 1/16, 2 cancel into that. I think it makes it 1/8. Is that true, guys? I think it's 1/8. I see 1/4, let's make that 2 over 8. I need to put all these numbers together. Let's make this 24 over 8. That's 3. Add all those up. I see 1 subtract 2 is negative 1. Oh, it's a negative 25 over 8. So his answer would be, now what? Is it, bracket? And negative 25 over 8, was it? For infinity, are we talking about that? For the range? Of this function with his help. Is that what you had in mind? And he says opening up, and he says if it's opened up, professor, there's the vertex right there. So the minimum is that up. And that's negative 25 over 8 through infinity. Genius. Congratulations. That's what you have to do. Now, tomorrow when I see you, I'm going to go back to these. Because we're going to be asking now not only do what I've done up there on this composite, but now find their domain and their range. That's why I asked this question. Go for it.
I have a question. So, if you have f of g, f of x and g of x are both rational functions, do you include the domain of f of x and g of x for the domain of f of g?
Whoa. You're taking me right into tomorrow. Hang on with that thought. I know exactly where you're going. Hang on. I got to do a little description tomorrow on that. I got you tomorrow. Guys, you have a short quiz tomorrow. So now you know what items the quiz will cover. 10 points only. I'm going to give you 40 minutes. Some students will probably take 10. So we'll give you a full 40 minutes to do those 2 problems. So I shall see you tomorrow.